Hey, what's up? This is Václav. Today we're gonna take a look at another display from Elecrow. But this time I won't use any third-party tools to program it. I will try to stick with the vanilla ESPHome. But what does it even mean? Let me step back a bit and compare it with the other methods I've used before. I made a video on each of them, so I'll link them in the description. First, I use the IT Nextion display. That one is just a display without the microcontroller. So you have to connect it to another device using the UART interface. The display HMI is created in a proprietary editor that is easy to use, but only exists for Windows. So if you're a Linux or Mac user like me, you have to get a Windows computer somewhere. Or I use Parallels Desktop, that works as well. The microcontroller can then be programmed in ESPHome. Nextion display is a native component, so that's straightforward. The whole HMI is created in the editor upfront, so from the code you are just changing the parameter values or getting events, for example when a button is pressed. Then I had a rather nice ESP32 display from Elecrow. It integrates the display and the microcontroller, so there is no tinkering involved. The HMI uses a LGVL graphics library, and you can program it in Platform IO or Arduino. It's basically a C code, or you can use MicroPython. So you have to be a programmer a little bit. But you don't have to create the whole design in a code. There is the SquareLine Studio, where you can basically create the whole application. The Studio exists for Windows, Linux, and Mac. It will generate the code that you can then load to the device from Arduino IDE, for example. I kind of like the program, it's quite powerful, but you still need to review and finish the code with some business logic, like the APIs to exchange the data with Home Assistant and link it with the interface. And I have struggled a bit with the LGVL versions. I had to manually copy the libraries from the demo app, otherwise it won't work. Although some functionalities like the components didn't work and some functionalities are limited to a rather expensive paid license. So both of these displays came with a quite nice HMI editor, so the design was easy to make. What my concern is, if I need to update or replace the display in a few years, will the application still exist? Will they still work? Will I be able to use it? And will I understand the Arduino code that I made a long time ago? So all the time I was looking for a display that I can just simply use from Home Assistant or from ESPHome. And I found it. And this is what today's video is about. Now, there will be some negatives as well, like we won't have those nice graphical HMI editors. And I'll be creating everything in ESPHome in the YAML file. But let's not get ahead of ourselves and let's get started. So here it is. The display is larger than the two I had before. A 5-inch display with 800 x 480 pixel resolution. It comes with a plastic frame and base plate, so you can easily mount it on the wall if you want. It has an USB-C port for power, and we can also use it to configure it. But there's also a battery connector. It has a micro SD card slot and then a bunch of connectors for speaker, UART, I2C and GPIO, so you can easily use them to connect external components. I'm not gonna do that today though. The display supports LVGL. You can program it in the SquareLine Studio like the one I used before. You can use Arduino IDE, MicroPython, Expressive IDF or Platform IO, but we're not going to use any of that today. We're going to program it in the ESPHome. So let's go to ESPHome and configure it. I'll start from a blank template. It has a ESP32 S3 chip, so I'll add the ESP32 section and choose the board type ESP32 S3 box. Then I'll need to pick the ESP IDF framework type. The Arduino framework will not work with the type of a display. The ESP IDF is the development framework created by Espressif themselves, and it's generally recommended for the ESP32 variations of the chips. Why is that important? Well, The way ESPHome works is it takes the YAML script and converts it to the source code, basically as C code. It uses the Platform IO IDE to compile the source code to the firmware using different libraries along the way. And the code, it can use either Arduino or Espressif framework. Some libraries work only in one of the frameworks, such as our display. Originally, ESPHome used just the Arduino, and it's still the default, but I think we are gradually moving towards the ESP-IDF. I believe the ESP-IDF is generally better, but I think the reasons why it is not a default yet is the compatibility, and it's also more complex. It requires more parameters to be configured. So let's add these. And we'll also need to add some parameters to the ESPHome sections for the Platform IO. I got these parameters from Elecrow, but don't worry. I added this device configuration to the ESPHome Device Configuration Repository, including the examples from Elecrow that do not use any specific Home Assistant entities. The link is in the description, so you can just grab it from there, compile it, and it should work. Then I can configure the API, OTA, updates, and Wi-Fi. That's the same for all the devices you have. Then there are three important components on this board that makes the display do its thing. The display, the touchscreen, and the backlight. First, the display. It uses a RPI DPI RGB platform. What a name. This requires configuring quite a bit of parameters. I show them on the screen, but you just grab them from the configuration repository. Now, to draw on the screen, we can use the standard ESPHome Graphical Functions API. There are some examples in the ESPHome documentation, so let's just steal one for the example. This one will draw 5 circles of different colors. And I also need to configure the light switch to turn on the backlight so that we can see what's on the screen. With that, I can compile it and upload it to the display's microcontroller. For the first time, I'll just plug it to my computer via a USB-C cable. And from then on, I can update it over the air. So here we go. I need to be connected via HTTPS, hit install, plug into this computer, then I pick the port, connect it, and wait. After it's uploaded, the device will boot, the display will turn on, and it will show the circles. So the display works. Now, to create the actual HMI, I just need to figure out the layout and draw it using these commands in the YAML file. There's no HMI editor as far as I know, but this is what we wanted, right? Do it in the vanilla ESPHome. I'd probably draw it on a paper or in a Photoshop and then translate it to these individual drawing functions. But it's quite complicated. But we now have full control over the screen. For a simple layout, that might be okay. If you just want to display some text, for example, perhaps with some color background. But to do more sophisticated HMI, it would not be practical. The API contains just primitive functions. Draw pixel, line, rectangle, triangle, circle, polygon, text, or an image. And there are functions for graph and QR code. So if you want to create some widgets on the screen, you would need to make each control using these functions. But wait, there is a much better way coming. Remember, the display uses the LGVL graphics library, and there is now a custom LGVL component for ESPHome. And what is even more interesting is that this is currently being integrated to ESPHome natively. There's a pending pull request in GitHub, so if I add this PR as an external component, I can already use it. And once this becomes part of ESPHome natively, I can just drop this external component section and it will continue working. So I guess this video is now becoming the first introduction to LGVL in Home Assistant. Really, this is huge because Unlike the drawing functions that are available now, the LGVL allows you to create easily a number of widgets. There is already the LGVL ESPHome documentation preview, so let me show you. This is the list of widgets currently available. There are also primitive drawing functions, but there are also ready-made controls, button, checkbox, switch, LED, drop-down box, roller, slider, even a keyboard. I'm not gonna go through all of them, but I'm gonna use a few of them to make a simple gauge. So let me show you. I configure the HMI in the LGVL section. There I can start adding individual widgets. Each widget has a set of parameters and they can contain a hierarchy of objects. Here is one I made earlier. I'm not going to explain the whole LGVL library in here, but let me just briefly walk you through so that you get the idea. So I'm creating dashboard as a demonstration for sort of energy management. So I'd like to show there 3 widgets, 3 gauges, with one showing the output of the solar panels. Then the middle one is going to show the state of charge of the battery and whether the battery is charging or discharging and with how much power. And the same thing for the grid. Are we exporting, importing, how much we are exporting, importing. So these are going to be the 3 objects. I'm going to show just one and explain you everything there is. And then I'm going to just highlight some differences for the other. So I'm going to just open the solar. So first there is a section that defines the size of the object. So the height 240 pixels and width 240 pixels. So it's going to be a square widget. And there's going to be no background, no border, no outline, no shadow, just a simple widget. What is going to be important is there is this alignment top left. Because if I'm going to compare it to the other object, the battery is going to be top mid. And then the grid is going to be top right. So there's going to be 3 widgets along the top of the display, one on the left, the solar on the left, battery in the middle, and grid on the right. Let's continue. And then within this widget, there is actually, this is a hierarchy. So there's going to be different parts of the widget. Again, that one has the size parameters, but that one is in percent. So this one is taking 100%, so full height and full size of the widget. This is going to be scales. That is going to take 180 degrees. So it's a half circle. This one is going to go from 0 to 10. So from 0 kilowatts to 10 kilowatts. This is what the solar panels can produce. For the other ones, I'm creating it from -10 to +10 because I can charge or discharge or export and import. So this one is going to be slightly different. And then there is 2 parts of it. First, there is the actual arc. So the arc that will, where the needle is going to go on the arc, showing how much power we are currently producing. So the arc is again from 0 to 10. It's 20 pixels width and it's got yellow color. And then the needle is there. And for the needle, I have configured an ID, power meter input. And with this ID, I can reference it from the rest of the YAML code, so I can update it from the script. So it's very important I do that on a number of items that are dynamically updated. Specifically, if you just look at that, there is going to be this label, which is going to be solar. This is an ID solar kilowatts, which are going to be updating with the actual kilowatts of the solar output. So we are now in the labels. So there is this label with the font Montserrat 40. So I have different font sizes that I have created here in the styles. So there's different font sizes created that I'm referencing down here. And then I have just simply 2 labels that go around the arc. One is showing 0 and 1/10, so the minimum and maximum of the scale. They use a smaller font. And as you can see, one is on the -95 and the other one is on +95. So one is on the left and the second one is on the right. And it's pretty much all there is. There's one more component there. There is the icon of the sun. that I'm putting in the middle below the gauge. It's using a reference to this image in here that I have defined with the MDI icon, so sun wireless outline, and I have two more, one for the battery and one for the grid. So this is all there is. This is the widget for the solar. For the battery, it's pretty much the same. As I said, it's top mid, this one. As I said, the scale is from -10 to +10. And there is one difference. The arc is actually split into two halves. One is going from -10 to 0 and the other one from 0 to 10. And they have different colors. So I'm making the negative part of the arc, I think a red color, and the positive part, a green color. So, and then I have added some additional labels in here. So there's the two labels for the scale, -10 and +10. And then there is the battery status. So is the battery charging or discharging? There is the battery kilowatts. So what is the charging or discharging power? And then the battery state of charge in %. And the rest is pretty much the same. I can use both the native draw functions and the LGVL in parallel, but let's keep it simple. I'll remove the native code and leave just the LGVL part. Then save it, install, and let's see what it does. Okay, so now we have an HMI, but it doesn't do anything. It doesn't show any values. To do that, I can update the widget parameters from the Home Assistant's values that I get through the APIs. So let's configure a few Home Assistant sensors. And for each, I'll add an automation to update the widget when the value changed. So this is my ESPHome configuration again. I have collapsed all the sections because I just wanted to focus on two of them now, the sensors and tech sensors. And as you can see, I've already configured 4 sensors and 2 tech sensors in there. I'm going to just show you what they are now. So it's really simple. It's a sensor using platform Home Assistant, which means this is not a sensor connected directly to the microcontroller, but it's coming through the API from the Home Assistant. This is a standard ESPHome component. You can find it in the documentation. And all it needs is there's an entity ID which points to the entity ID in the Home Assistant where the value. So in this specific example, this entity ID holds the photovoltaic power output. So in ESPHome, there is going to be a sensor with the ID PV power that is going to have from Home Assistant the current photovoltaic output. And I have configured an automation on value, which means that when the value is updated, it will then update the LGVL. It'll update two things on the LGVL. It'll update the label, so it will update the text, and then there's a formatting string. This is coming from a C code, but really simple. So it basically says it's a number. They call it a floating point number. So it has a decimal part, and I'm saying I want to see one decimal number here. So this is this %.1f. And at the end, I like to say kilowatts, so the unit of measure. And then for the argument, I'm saying x divided by 1000. What does the x mean? For the automations on value, it actually puts the value that is being updated to x variable. So that's how it works in ESPHome. So I'm basically saying I'd like to display on the screen the value of the PV output, but I'd like to divide it by 1000 because the value is in watts, and I'd like to convert it to kilowatts. And therefore I have the decimal part here. And then I'm also updating the needle, the indicator. So again, there is LGVL indicator update, and I'm saying the new value is x divided by 1000. And that's all there is. I can show you there is one more for the battery power. Pretty much the same thing, except the entity ID is sensor battery power. And I'm saying I'm updating the label ID battery kilowatts. For the state of charge, again, same thing. There is an entity ID battery state of charge from Home Assistant. And here I'm not dividing it by 1000. and the format is slightly different. I'm saying I'd like to see the percentage with 0 decimal points, and I have this double percentage here because percentage is used as a formatting string, and if I want to see really the character of percentage, I have to write it twice. This is really coming from a C code, so just use it as it is. Same thing for active power, same thing as the photovoltaic and the battery power. And then I have the text sensors here that update the state, whether the battery is charging, whether we are exporting or importing. Similar thing, it's a platform home assistant, entity ID, sensor, battery mode, but this one doesn't contain number but a text, and therefore I have it in the text sensor. And for the update, I'm again using LGVL label update of the ID battery status, and in the text I'm using a lambda with the X again, but I have to use the C str to convert it to a static text. It's again part of C code, but you don't have to worry about it, just use what there is. And I have the same thing for the grid status, importing, exporting. And that's really it. So again, save, compile, the device will reboot, it'll connect to Wi-Fi, connect to Home Assistant, and in a couple of seconds it'll receive the values and update the display. Right, so that wasn't too hard, was it? It's basically the same I did with the IT display, but here I didn't have to create the layout externally, but everything is done from the ESPHome script. There is one more thing to do. The display now shows the widgets, but the touchscreen doesn't do anything, so let's add it. It is a standard GT911 component, so I just add it. It uses I2C bus, so I just need to add that as well, and we are done. Now the touchscreen works. I can, for example, add an automation on the raw values. It'll be called with the X and Y coordinates when I touch the screen. Or more practically, I can create binary sensors for the buttons on the screen. So let's add a button for each of the widgets. I know their size, so I'll just add the X and Y coordinates for each. And I can then trigger an automation from the button when it's pushed. For now, let's just log a message so that we know it works. Compile it, and let's see. When I push one of the widgets, I can see the message in the log, so it works. I also gave these binary sensor names, so they were discovered in the Home Assistant as entities. So when I touch the widget, it will automatically show in the Home Assistant. So I can trigger automations from there. So here I have it, the ESP32 touchscreen fully configured in ESPHome. Now we have 3 options and know their advantages and disadvantages, so you can choose the one you like. In fact, one more option I didn't mention. You can always get a tablet or display with a Raspberry Pi and show a Home Assistant dashboard on it. But we can perhaps leave it for another video. Until then, bye!